All right. Hello, everyone. Thanks for jumping on to today's IBN Hotline. Today we have Aaron Broyens, who is essentially going to be providing a recap of last week's SEVT innovation session. He's going to be providing an SD-WAN overview for the 17.3, 20.3 release, as well as going into some of the new 17.4 features. We have panelists on the call ready to answer your questions in the Q&A panel during the actual presentation. At the end, we will leave a few minutes for live Q&A if you prefer a verbal response to your question. And at that point, I will just ask that you raise your hand and we will unmute you in the order in which the hands go up. A quick call out, since I know we have a lot of SD-WAN folks on today's call. Next week's session will focus on SD-WAN quality and roadmap updates. So if you don't have that session on your calendar for some reason, please access cs.co/IBN hotline to add it to your calendar. There you'll also find links to previous sessions, recordings, and presentations. All right, I think that's everything. Aaron, passing it off to you.
All right, thank you, Stephanie. Okay, so yeah, as Stephanie just mentioned, this will be mostly a recap of what you might have seen in the innovation session at SEVT last week. I know we had some overlap with some DNA Center sessions and whatnot, and a lot of folks were not able to join the SD-WAN innovation session. So we had actually had this particular session scheduled out for a couple weeks. So I thought it was a good opportunity to recap a lot of the stuff that we talked about in the BT innovation session. So again, in case some of you guys or some of you folks missed that session, this will be a recap of that. And for those of you that were able to attend, we've got quite a few TMEs and some of the TSAs that were able to join us on the panel here today. So if you have any questions as we go through some of the stuff that you might have seen last week, definitely throw it in the Q&A panel. We'll try to get your questions answered as we go. Now, you'll probably notice as we go throughout this presentation, as far as the agenda goes, we're going to try to cover like a lot of major features that have come in 17.3 and 17.4. The primary reason for this is really just want to make you guys aware of what kind of tools are in your tool belt that you can use to sell or that you can use to compete against, you know, a lot of the competitive FUD that is out there, things like on-demand tunnels and adaptive quality of service and all that crazy stuff. So try to give you an idea of all the different features that are available. This session is not going to give you a complete 100% in-depth, you know, deep dive on each one of these features. It's more or less just to introduce you to the feature so you know what it is and you know what it does and you know how to compete if it's ever brought up in any of your deals. You'll notice on this, however, that there's a couple things that are absent in this presentation. One is the lack of security and then the lack of cloud. We do have a couple updates on security, but security is kind of becoming its own beast right now. There's a lot of features, a lot of stuff that's been added from Umbrella SIG and whatnot that kind of deserve its own session. Same thing for cloud with AWS Transit Gateway support, Microsoft Azure vWAN, and you know some of the SaaS updates and whatnot. If you're interested in a deeper dive on that stuff, they actually had their own dedicated sessions within SEVT for during last week's sessions. So if you're interested in a deep dive on that kind of stuff, definitely keep your eye out for some of the links that were posted for those security and cloud sessions, the multi-cloud sessions. That'll give you a pretty good overview of what's coming in 17.3 and 17.4. So everything outside of cloud and security is what we're going to focus on here today. So monthly app quality of experience and the core innovation updates that you'll want to be aware of. And we're going to kind of jump all over the board here, so I apologize. It's hard to kind of keep some synergy with a lot of these features, so just bear with me and we'll kind of dive into each one of these directly. So the first piece we'll kick off here with security. We talked about this in the innovations sessions as well, but one of the biggest enhancements, I guess you could call it, with 17.3 is the addition of TrustSec and SGT transport. So for those of you that are not aware, or in releases prior to 20.3, we did not support SGT tagging technology. So if I'm assuming most people on the call are probably already aware what TrustSec is and what it does. If you're not, I mean, you know, the simplest thing I can say, just in the interest of time, is that it is a tagging technology that provides security context for traffic on the network, right? So if you think of like DSCP and quality of service markings, how that provides a prioritization of traffic or a preference for traffic, this is a SGTs provide a similar concept, but in the realm of security, right? So security now has a most devices have a security context when it comes to processing traffic. So what that means in the grand scheme of things is that we can now make security decisions anywhere we want on the network, right? At a switch level, we can drop traffic at the all the way down to the access port based on the SGT tag that we have assigned to a particular user. Now, what this means in the context of SD-WAN is as of this moment, or I guess as of up to 20.3, we've not been able to transmit those SGT tags from one side of the network to the other side of the network. So in other words, if you look at the picture here, on the left side there, you see a user, right? And he's transmitting traffic into, to a branch on the right side of the picture. As that traffic enters the network, as it hits the switch is going to attach an SGT value to the Ethernet header, or a tag value to the Ethernet header. Prior to 20.3, as soon as that traffic hit the SD-WAN router, we'd have to drop it because the SD-WAN router wouldn't understand what that tag value is. And so essentially, TrustSec and even SDA would break at the SD-WAN router. As of 20.3, however, the 20.3 SD-WAN routers, or I guess I should say version 17.3 of iOS XE and version 20.3 of SD-WAN, we can now understand that SGT value, right? So as that traffic progresses up to the SD-WAN router, we can take that SGT value out of the Ethernet frame, out of the Ethernet header, and move it into the IPsec header, into the ESP header, more specifically. We can then transport that SGT to the other side of the network. Once it hits the other SD-WAN router on the right side of your picture, that SD-WAN router will unencapsulate that traffic, pull that SGT out, put it back into the Ethernet frame, and then send it on its merry way, right? So the concept is that we can extend, we can now take TrustSec and we can extend it all the way from end to end, from the left side of the drawing to the right side of the drawing. Now, this particular presentation has a bunch of hidden slides and a bunch of additional slides in here to kind of describe some of the use cases where you might see this in the wild. So we already basically just described this use case that you're looking at here, but since this presentation is going to be made available to you on Sales Connect, in the interest of time, I'll skip some of these slides, and then you can go back and take a look at them in your own time if you'd like a little bit more color on how you might see this in the wild. So shifting gears here to the next big feature that came with actually it came with version 20.1, but it was made even better in 20.3. That's unified communications. This has been a very, very, very big ask for a long time. And for those that are not aware, I'm a big context person. I want to understand the context behind the feature, why we're introducing it, what does it mean for SD-WAN, what's the overall context to this. With unified communications, I've said this before, but again, in the interest of context here, when Cisco purchased Viptela, one of the decisions that was made was to add the Viptela capability into our ISRs or into our routing product family, ISR 4Ks, CSRs, ASRs, and the works. The issue that we ran into, however, is the Viptela capability was a rather large ask from a memory footprint, right? So it needed a lot of RAM in order to run the Viptela capabilities. Unfortunately, so does iOS XE. So the existing operating system that we had on our routers also needed a lot of RAM in order to operate efficiently. Most ISRs would have shipped with 4 gigabytes of DRAM. In fact, almost all routers shipped with 4 gigabytes of DRAM. So the decision was made, let's strip down iOS XE, strip out a lot of features so we can try to get the memory footprint a lot lower, then we can squeeze Viptela code in there, right? And we can give our customers a very clean transition path so that they could do a simple in-place upgrade of their existing ISRs from the legacy iOS XE to Viptela or SD-WAN XE without having to do a truck roll, without having to do any kind of memory upgrade or anything like that in the router. Unfortunately, one of the pieces that we removed was unified communications capabilities. And as a lot of you guys know, that is a big differentiator for Cisco. We are the only SD-WAN vendor that offers natively integrated unified communications within our branch CPEs. We're the only vendor that can terminate a voice phone call on the CPE itself. You know, we can do DSP farming, we can do survivable remote site telephony, all that fun stuff. We're the only vendor that can do that, and to strip that out removed part of our competitive advantage. So moving forward, in version 20.1, we released the first phase of unified communications. So that was released earlier this year. That brought support for analog circuits, things like FXO, FXS ports, DSP farming, or I'm sorry, not DSP farming, but SRST, survivable remote site telephony, as well as things like a T38 faxing and so on and so forth. In version 20.3, which was just released a few weeks ago back in August, we brought in support for DSP farming as well as digital circuits like T1, E1, PRI, and that sort of thing. So at this point, we've satisfied, you know, I would say 80 to 90% of most branch UC use cases. Right, so most of our customers that are utilizing unified communications out at the branch, this is what they're going to need from a feature perspective. They're going to need SRST, they're going to need DSP farming, they're going to need analog and digital T1, E1, PRI termination. Now, a couple things to call out here so you guys are aware. Number one is this is a SIP-only implementation of UC. Okay, so you can see down there in the lower left-hand corner, the H323, MGCP, and SCCP call control protocols are not supported. So chances are, for those of you that have customers that are interested in moving to SD-WAN now that UC is available, you're more than likely going to run into some customers that are running legacy protocols like that, H323, MGCP, or SCCP. If you do, you'll need to think about a migration plan to get them on SIP and move them to SIP first before you make that migration. So I'm seeing the questions come across on the Q&A panel here. What about Cube? Cube is coming. Right now, engineering is, we're trying to scope that out and figure out exactly what our timelines are on that. Don't hold me to this, but it's looking like sometime around the 20.5 to 25 range. So sometime early to mid next year is probably when we're going to get Cube integrated into the UC fold here. So it's a good call out, you know, and for those that are, you know, kind of reading between the tea leaves here, Cube is not supported at the moment. We support basic SIP trunking. So it more or less means if you're trying to build a simple SIP trunk between the gateway and call manager, or the gateway and some other call control server, you know, perhaps that a service provider is providing for you, you can build those simple SIP trunks, as I would call them. If you're trying to do anything advanced, you know, IP to IP hairpinning and all that kind of crazy stuff with Cube, you're not going to be able to do that. That is something that's going to have to wait until next year, early to mid next year, when we get Cube support. Now keep in mind, again, the way we scoped this out was we wanted to try to satisfy all the branch use cases that we could. That's why we brought in SRST, DSP farming, analog digital support, all that stuff, so we could satisfy all those branch use cases. Totally get that Cube needs to be supported, so we are going to try to get that supported, but hopefully, and in many cases, Cube is typically seen at an aggregation site or a hub site. Not all the time. There are some customers that run Cube out at the branch, and for those, we'll have to be careful how we tread here. But for the most part, a lot of customers run Cube at the hub site or aggregation sites, and in that case, it makes more sense to, you know, have a dedicated router for Cube for the time being, and then when we get support in SD-WAN for Cube, you can get rid of that router at the hub site and move Cube functionality onto the SD-WAN router. Now, one other thing I'll call out while we're on this slide, just so you guys are aware, is T1 PRI support. Now, I mentioned just a moment ago that we support T1, E1 PRI within SD-WAN now. We do. The only caveat I want you all to be aware of is we do have some customers that are they have an interesting use case here. So for some customers, they need high-density DSP farming, right? So I'm kind of shifting gears here for a moment to explain the context. But some customers need high-density DSP farming, right? So they need a lot of DSP resources and PVDMs within the router. For those UC folks on the call, if you know much about ISRs or ISR 4K, there is only one PVDM slot on the motherboard of an ISR 4K. So there's only so much DSPs or only so many PVDM resources that you can squeeze into the router. Moving forward, what a lot of customers did is they decided to purchase a T1E1 NIM module, which you can see in the lower left-hand corner. These are the type of modules that a customer would have purchased. And what they'll do is each one of these modules has its own dedicated PVDM slot on the module itself. So what the customers used to do is they would purchase a bunch of T1E1 modules, load up their router with these NIMs, put PVDM chips inside each one of these modules, and then they would never even plug in a T1E1 line into any of these modules. They would just basically farm out all the resources from these cards to make one big giant pool of DSP farm resources. There are some customers out there that are doing this, so it's kind of a way to skirt the issue here and get high density DSP farming on a router, you know, by using T1E1 NIM modules without actually using them for their intended purpose. Moving forward, unfortunately, we are not going to support that anymore. We cannot support farming out DSP resources off of the T1E1 blade and using it for DSP farming. So whatever PVDM chip you have installed on that NIM for that T1E1 module is going to have to be used for that module. In other words, to bring up the PRI. However, we have a new module that's being introduced that was introduced in 20.3 called the NIM PVDM, which you can see on the far right-hand side of your screen here. The NIM PVDM 32, 64, 128, and 256. This is specifically to address the use case I just described. If there are some customers out there that are utilizing you know, the DSP resources and PVDM resources off of their E1 modules that are no longer going to be able to do that with an SD-WAN, this module exists to satisfy that use case. Now, if you run into a situation where your customer is doing exactly what I just described, and this is going to create a lot of heartburn to get them to move to SD-WAN, because they're going to have to swap out a whole bunch of T1E1 NIMs for these new NIM PVDM modules. If that's going to create a lot of heartburn, definitely reach out to myself or reach out to any of the other UC product team and let us know. I'm sure the PM Chitrang would be happy to work with your customer to see if there's anything we can do about credit or whatnot or exchange to get these new modules in their hands. At that point, the only downside then would there's a truck roll involved. Somebody's going to have to go out and swap out those modules. All right. So fax modem support, we kind of touched on it just a moment ago. Fax modem is also supported for those folks that are interested, particularly in the hospital verticals or healthcare vertical, I should say, and financial verticals. There's still a lot of fax machines in use and modems and whatnot. We do now support that within SD-WAN, so you can through T38 and modem and fax pass-through. That is supported. So if you have a customer in either one of those verticals or any vertical for that matter that's still using fax machines or modems and they want to proceed with SD-WAN, this is still available, or this is still a viable option for them. Now, before I cut out of UC configuration here, or UC, the UC update, you do need to be aware as well, pardon me, if you're not really a UC guy or a UC engineer and everything I just talked about makes absolutely no sense to you and you don't care to know any more about UC, that's perfectly fine. The only thing you need to be aware of is vManage is essentially going to have some new templates to configure UC functionality on the router. There is no additional controller to be aware of from an SD-WAN perspective. vSmart really isn't even aware of any of these phone calls, anything that the router is doing. There's no special routes, there's no special OMP updates or anything like that that have been added. We're really just talking about some new templates that were built into vManage to push down UC functionality onto the router configuration-wise. Once that functionality has been pushed down onto the router can then interact with the call control servers via the data plane. Okay, so shifting gears here a little bit, let's shift over to multicast. Multicast is the next big feature that came. Now this is kind of a two-part update. The first one is, and I want to make it clear here, in version 20.1, multicast capability came to C-Edge. So as of version 20.1, we had complete 100% parity between V-Edge and C-Edge with regards to multicast and being able to forward multicast traffic across the SD-WAN fabric. Version 20.3, however, is extending the multicast capability to also include intelligent routing, right? So now with version 20.3, you can actually create SLA classes with your application or routing policies within SD-WAN, and you can intelligently route multicast traffic based on those AAR policies. So if we take it again in the context of in the context of something like unified communications or IPTV or some other kind of business critical application that uses multicast as a transport mechanism, you can now create an SLA policy on the SD-WAN fabric or centralized data policy that will ensure that multicast traffic takes the most efficient path that we have available that maintains a certain SLA level for that particular audio stream or for that particular multicast stream. So biggest use cases I can think of for this would be things like IPTV, or even in the context of unified communications, something like multicast music on hold, right? Now your application or routing policy can intelligently route that multicast music on hold or IPTV across the SD-WAN fabric. Keep in mind, however, multicast application or routing is only available on C-Edge. So while we do support multicast, just basic multicast on both platforms, multicast AAR is going to be a C-Edge only feature. Next big update is dynamic on-demand tunnels. This is one of those big ones that our competitors continually hammered us for because we didn't support it. For those that aren't aware, again, just to set up some context here, when you boot up an SD-WAN fabric for the very first time, you boot up, some routers and whatnot, boot it up for the very first time, it's going to boot up in a full mesh fabric, right? So every site is going to attempt to talk to every other site and build an IPsec tunnel to every other site. In most organizations, particularly smaller and even medium-sized organizations, that's not really that big of a deal. We can have IPsec tunnels going everywhere, not a big deal, it works just fine. When you start to think about organizations that have, in the hundreds of sites and we have multiple transports at each site, now we're getting to a point where we can start overloading the router from a computational perspective. So if you think of it, if I've got just a couple hundred sites, like 200 sites, and each site has two transports, MPLS and internet, or two internet connections, right? Simple math says that's going to be about 400, 400 give or take tunnels, right? From a full mesh perspective. The problem is we have some platforms that are not capable of 400 tunnels, right? Some platforms, lower end platforms like the v-edge 100 is only capable of 250 tunnels. So this created some heartburn with some customers, and they had to adjust policy and create hub and spoke policy and do fancy things in order to prevent certain sites from creating full mesh tunnels so that we could, get below the tunnel scale limitations of some of our platforms. Particularly when you're thinking about very large organizations with tons and tons and tons of sites, this can become a very big issue and can become a very big scalability problem for big organizations. This is where we typically got hit from a competitive standpoint because we needed additional policy to undo this default capability. Starting with version 20.3, however, you now have the capability of running dynamic on-demand tunnels. So what dynamic on-demand tunnels allow you to do, for those folks that have messed with IWAN before or messed with DMVPN and NHRP and all that fun stuff from a previous, from previous SD-WAN solutions, that same capability is now coming to Viptela SD-WAN, right? So dynamic on-demand tunnels will mimic DMVPN. Now we're not using NHRP right? As a resolution protocol, vSmart already maintains most of that information that we need. So vSmart is the one that's actually going to be handing out a lot of that next hop information for us. But dynamic on-demand tunnels, what it is it allows when our routers boot up for the first time, once they've been configured for dynamic on-demand tunnels, they will maintain an always-on tunnel to the hub site or to a co-location site or whatever site you dictate. We call that the backup path. And then as needed, if, for instance, on your diagram, the router on the left wants to talk to the router on the right, it will build an on-demand IPsec tunnel to that router on the right so that it can send its traffic over there. So this greatly helps from a scalability perspective and a computational perspective. Now our routers, even though we have the effect of full mesh traffic, we're not actually having to maintain a full mesh network. So it saves us a lot of CPU resources, a lot of computational resources from that perspective. Supported on both V-Edge and C-Edge. Next piece to talk about in the realm of quality of experience and quality of service and all, you know, all that fun stuff when we talk about dynamic on-demand tunnels and whatnot is adaptive quality of service. This is another big feature that was prevalent, you know, pretty prevalent in IWAN and DMVPN days in terms of PFR and whatnot. If you think about it, in IWAN, we used to have this notion of per tunnel QoS. Okay, so per tunnel QoS was introduced in 20.1 of SD-WAN code back earlier this year. Adaptive QoS builds on the per tunnel QoS idea. And if you're not familiar with what it is, it's exactly as the name would imply. The hub site routers can actually track and maintain the bandwidth capabilities of all the branch sites that you're attempting to send traffic to. Right, so if a hub site is attempting to send traffic to branch 1 and branch 1 only has a 100 meg circuit attached to it, but the hub site has a gigabit circuit attached to it, the hub site can actually shape its traffic or throttle its traffic down so that it only sends 100 meg worth of traffic towards branch 1 so that we don't overrun that branch and run into a far end drop situation where, you know, a lot of traffic's getting dropped at the far end simply because it exceeds the capacity of the circuit. That's what per tunnel QoS allowed us to do, is that shaping mechanism on a per tunnel basis, on a per branch basis from the hub site. Now, adaptive quality of service expands on that or enhances that capability a little bit to make it a little bit more dynamic, hence the word adaptive. And basically what it means is as your hub site is attempting to send traffic towards your branch locations, your branch locations can actually advertise what their current bandwidth capability is, right? So even though we might have hard-coded that we have a 100 meg circuit attached to this branch, at any given moment, the branch, you know, somebody might be on Netflix, YouTube, whatever, you know, and they're surfing the web. We might only have 80 megs of available bandwidth at that given moment. That branch can actually advertise the capabilities that it has, the bandwidth capability that it has to the hub location. And so now the hub location can actually shape or throttle its traffic even further in order to compensate for the fact that this is maybe a busy circuit right now, right? So again, the whole point here is that we avoid that far end drop, right? And avoid the situation where we're dropping most of our traffic at the far end because the circuit simply can't handle any more traffic. That's a bad situation to be in, especially when you're talking about business critical traffic. Even though you're prioritizing it at the hub, by the time it reaches the far end, it might be dropped, you know, indiscriminately, simply because it exceeds the capacity. With adaptive QoS and per tunnel QoS, we can prevent that from happening. In other words, we know how much bandwidth is available at the far end, so we can make sure to squeeze everything we need, all that business critical traffic. That's going to go out the door first. And make sure we squeeze it all into a profile that the branch is advertising to us. Next thing, again, in the realm of application quality of experience and quality of service, and so to speak, is multiple service nodes for app QoE. Now, app QoE, or service nodes, I guess I should say, were a concept that were introduced in 17.2 and 20.1 earlier this year. The concept here is if you're doing things like TCP optimization and other features down the road, but primarily things like TCP optimization, if you're doing anything like that at your branch locations or even at your hub site locations, that can be rather CPU intensive or computationally burdensome on your routers. Now, multiply that a bunch when we're talking about the hub site or the aggregation router that's aggregating a lot of connections for all your branch sites. Even if that's an ASR, we're talking about a lot of CPU overhead in order to turn on things like TCP optimization. So we introduced this concept of service nodes back in 20.1 that will allow you to offload that computational burden off of the ASR and offload it onto a dedicated box that can perform that optimization for us. We call them service nodes. They're nothing more than CSR 1KVs, right? So it's just a virtual CSR sitting in like VMware or Hyper-V or something like that, but it's nothing more than a virtual router sitting adjacent to the ASR, right? In 20.3, or I'm sorry, I guess I should say 20.4, 17.4, we're introducing multiple service nodes for AppQoE. So really all this is going to do is give us additional compute capability, if you will, or TCP optimization capability. So now you can have multiple service nodes, I think up to 6, if I'm not mistaken, up to 6 sitting adjacent to that ASR, all performing TCP optimization functionality and offloading that capability off of the ASR or the hub site router so that it can scale higher. All right. Now, next big feature for 17.4, and I'm trying to stay within the theme of application quality of experience here, but it's per-class BFD probing for AAR. If I had to pick one feature that was the most asked feature over the past 2 years that this product has been developed, it is this feature. For those folks that were coming from an IWAN background, not to keep going back to IWAN, one of the things that IWAN did pretty well in many aspects was that it had per-class probing. So the downside with Viptela, with the Viptela solution up until 17.4, is the fact that when we probe, when we try to measure loss, latency, and jitter between 2 pairs of sites, we are, the probing mechanism that we use is BFD. And each one of those BFD packets that we create and we send from one side of the network to the other side of the network, each one of those probes is marked with a DSCP value of 48, or CS6 in other words. The problem with that is, or the problem with marking all of our probing traffic with DSCP 48 or CS6 is that is not accurately measuring all of the quality of service, all the queues that our carrier or our service provider might have set up for us within the MPLS cloud or within our private network transport. So if you think about it, if your service provider, your customer service provider, has a dedicated voice queue where he's providing low latency queuing and he's providing preferential treatment to all traffic that's marked with DSCP 46, but yet we're sending BFD probing traffic in marked with DSCP 48. Unfortunately, we're never going to get a true reading or a true sense of how that DSCP 46 queue is performing because our traffic is never going to be delivered to that queue. So with this feature, what we're attempting to do is similar to what IWAN did, is we will allow the administrator to adjust the BFD probing mechanism so that we can mark it with different DSCP values, right? So that in this way, we can actually probe individual quality of service or class of service queues within our MPLS or our private circuit provider. We can probe each one of those individual queues and get a much more intelligent reading on how each one of those queues is performing. So again, if you have a unified communications application-aware routing class, for instance, previously, if we're marking everything with DSCP 48, we're not going to get an accurate measurement of how UC traffic is performing across our SD-WAN fabric. It'll be close, but it won't be accurate, 100% accurate. Now with 20.4, you can actually create a dedicated BFD probing class for that SLA class that will mark BFD probes with DSCP 46. And therefore, we can actually measure end-to-end how DSCP 46 traffic is transiting your service provider. And therefore, furthermore, I should say, your application-aware routing policy is much more intelligent in terms of how it routes traffic based on how that traffic performs across the underlay. right? So very, very, very big feature. It's been asked a ton over the past couple of years, and it's finally making its way in 17.4 and 20.4. So we have customers currently testing this in EFT. Custom app support is another big one that's been asked for a long time now and finally making its way in. The big caveat I want to, as the name would imply, this is creating custom applications within your SD-WAN fabric. Big caveat I want to call out here is this is only on C-Edge. You need to be aware of that because this requires SDABC support in order to run. But the idea here is we have a lot of customers that are creating or that have custom homegrown applications or whatnot, and they want to be able to reference those applications within their policies. And up to this point, they might have to create a whole bunch of data prefix lists. They might have to create, various lists within policy, I should say various match conditions within their policies in order to match on a particular homegrown application. What this allows you to do is create the application. You can identify it based on URL, the host name, IP address, port number, layer 3, layer 4 protocol, or I'm sorry, I should say layer 4 protocol. You can identify the custom application here within the custom applications menu, and then you can call that application up within policies. So your match criteria for your policies now get quite a bit more simple. You're not matching on 5 or 6 different things. You can match on a single application, and that single application match makes your policies easier to read, and it's much more reusable. I can reuse that same app in all policies across the board. So it also eliminates things like fat fingering, for those cases where I might miss a match condition on one of my policies or one of my sequences or something like that. All right. Now moving into some of the core functionality, some of the core features that also came with 17.3. One of those is service-side NAT. Been a big ask as well. All this stuff, if you haven't noticed, has been a fairly big ask. This has been available in v-Edge for a long time, but it's one of those feature parity asks where a lot of customers have not been able to move forward with C-Edge or with ISR because we don't support service-side NAT. So they've had to move forward with v-Edge because that was the only platform that supported what they wanted to do. So we see this a lot in mergers and acquisitions or even in service provider environments where you might have multiple branches that have the same IP prefix associated with them. So branch 1 and branch 2 have the 192.168.1.x/24 prefix associated with it. How are you going to get branch 1 and branch 2 to talk to one another? So this feature in particular allows you to NAT those prefixes to a completely different address space so that those two sides can talk to one another, so that the left side can talk to the right side. So if you look at the picture here, basically what we're doing is we're NATing the left side to the 10.11.x/24 address space, and we're NATing the right side to the 10.00.x/24 address space. So that way, both these sides can talk to one another, and from each other's perspective, they see the other side as some 10 address, not even knowing that the other side's actually a 192 address. So this really helps. The use case for this, like I said, a lot of times in service providers, you'll run into this situation, but even more prominent in mergers or acquisitions where we acquire a company, and the company that we acquire happens to have, several branches that are running the exact same address space that we are running on our branches. How can I bring those branches into the SD-WAN fabric so that they can talk to, resources that they need to get to within my organization? This is precisely when you would use a feature like service-side NAT to enable that connectivity. We got 3 new trackers that were available, that became available, I should say, in 20.3. The first one is DIA tracking, or DIA tracker support with C-Edge. Now, this has been available again on v-Edge for a while now, but it's one of those things where you had to, shoestring, Band-Aid, duct tape the C-Edge to get it to do what you wanted with EEM scripts and all kinds of crazy, kooky stuff to make it work. It's now officially supported through a dedicated tracker functionality within 20.3. But the notion is here, the concept is, if I want to enable direct internet access at my branch, I want some mechanism to be able to probe the internet off of that circuit and make sure the internet is still accessible off of that circuit. If for some reason it becomes inaccessible or a brownout condition, I want to be able to withdraw my direct internet access off of that circuit and then offload that traffic to some other circuit, right? So maybe backhaul it across MPLS to a data center or a co-location and send it out that way. That's the whole idea behind this feature. And what DIA Tracker allows us to do is we can turn on ICMP probing. For those of you that have turned on IPSLA within iOS routers before, very similar concept, very similar configuration, syntax, and whatnot. You're just turning on ICMP probing towards a destination. You're going to ping a destination, and when you start encountering loss on that destination, we can automatically withdraw a default route, and which will automatically install a new route to push traffic through a data center through a co-location facility. Now, along with that, we also got static route tracker support in 20.3. And what this is kind of the same concept here, except in a branch, you might run into a situation where instead of sending traffic directly out to the internet through a direct internet access circuit from the SD-WAN router, you may want to send that traffic to a firewall first, or a lot of customers like to do that if there's an on-site firewall. So in that case, your default route that you have might be a 0-0 route pointed to a firewall that's sitting adjacent to the router at that branch location. So what we'll do in that case is we can actually probe the default route towards that firewall. So we can probe the firewall basically and make sure that the firewall is still responding back. Same concept, we're still using ICMP, so you need to make sure on that firewall that you open up ICMP and that it's actually going to respond back to ICMP probing or ICMP ping requests, echo requests. But as long as that firewall is responding back, we will continue sending traffic through the firewall to get out to the internet. If the firewall stops responding to ICMP for some reason, because it, a policy mismatch or some sort of issue on the firewall, or it fails, whatever the case may be, once those ICMP probes start to fail, we can then fail over perhaps to a direct internet access link. We can start sending that traffic directly out to the internet, or we can backhaul it across to SD-WAN, whatever you want to do. The point here is that we can automatically withdraw that route out to the internet and move on to a different route so that we're not black holing that traffic. Now, the third tracker that we got is similar in functionality, same concept, same ICMP probing and all that stuff. But the difference here is that you might have some customers that are using service insertion. And if you're not familiar with service insertion policies, they're not heavily used at this point, but some customers do use them. Service insertion policies are exactly what the name implies. As traffic is leaving my branch, I want my branch site to automatically forward that traffic to take Office 365. I want my Office 365 traffic to go through my F5 load balancer, and I want it to go through my Palo Alto firewall or my ASAV or my FTDV before it goes out to Office 365. It needs to go through those two devices. I can create a service insertion policy that will force my branches to find a site that is advertising the firewall functionality or advertising this F5 load balancer and the ASA. Find a site that's advertising those two capabilities and send the traffic to that site first so that it can be processed through that site. Then it can go out to the internet. The same downsides exist on this, however, is what happens if those devices all of a sudden become unavailable, right? What happens if that F5 load balancer dies, or what happens if that Palo Alto or ASA or FTDV dies, right? Same concept exists here. We can set up a tracker to track the status of those devices, and if for some reason they become unavailable, we can actually withdraw those devices from the service insertion policy and therefore not black hole that traffic to make sure that traffic still processes at, the way it normally would out to the internet, perhaps bypassing the service insertion policy altogether, just so we don't black hole it. All right, one of the last couple features to talk about here is enhanced route leaking. Again, I know I say this with every feature, but it's another big ask. But the notion here, the concept here is what happens if I have a device or a service that my service provider is hosting within the underlay, within the MPLS underlay, and I need to provide access to it, right? So a good use case here is, particularly for you UC folks who might be looking at moving a customer from Unified Communications, moving them into SD-WAN now that Unified Communications is supported, what happens if there's a SIP trunk or a SIP registrar that lives, that perhaps my service provider is providing for me that lives in the MPLS underlay? How can I provide access to that service without having to turn on NAT and having to turn on, having to recable things and go through all kind of wonkiness to allow that traffic through? With 20.3 and 17.3, we now support enhanced route leaking, or I should just say route leaking between VPN 0 and VPN 1, or any service VPN for that matter. But the idea here is I don't need to turn on NAT. I don't need to do anything special. I can forward this traffic directly into the underlay untouched and leak it between route tables so that, in the case of UC, my phones or my gateway appliances can actually reach that SIP service in the underlay uninhibited, right? So I can set up two-way communication with devices that are outside the SD-WAN fabric using this feature. Again, I typically see this in UC, within UC, but obviously there's a ton of other use cases for it where a service provider or somebody is hosting something in the MPLS underlay or within the underlay anywhere for that matter, and I need to provide access to it. This is where you might use a feature like that. vManage multi-tenancy is also now fully supported with 20.4. So when 20.4 drops here in just a couple weeks, you will have the capability of running vManage multi-tenancy or multi-tenancy. It will be officially supported, so to speak. Now this stretches across both vEdge and cEdge. But the key thing to keep in mind here is with this support comes full support for controller multi-tenancy. Now previously, when we talked about multi-tenancy, only vManage and vBond was multi-tenant capable. vSmart, however, you needed a dedicated vSmart appliance per customer. And for a lot of service providers, that was a big ask, right? A big computational ask, a big compute footprint ask, because for a lot of customers, you might need a lot of RAM and CPU to spin up a whole bunch of vSmarts. With 20.4, vSmart is now multi-tenant aware, right? So with 20.4, all of the controller elements can now support multi-tenancy. You can now share multiple customers on each one of these controllers, so you can minimize your compute footprint, so to speak, and still host a whole bunch of customers off of each one of those controllers. Now, the one thing to highlight on this particular slide is this is not referring to data plane multi-tenancy. Data plane multi-tenancy is still coming. It's still on the roadmap, probably sometime next year. I'm not really sure on versioning or whatnot, but probably sometime next year. The idea behind data plane multi-tenancy, however, is where I have a router, a single router that belongs to multiple customers and is going to register to multiple vManages. So keep in mind right now, even with 20.4, when we're talking about multi-tenancy, customers still have to have their own dedicated router because that router is going to register to that customer's vManage and that vManage only. Down the road, when we talk about data plane multi-tenancy, now you're talking about a single router that is basically split brain, and part of it is registered to one customer, customer X's vManage, and then the other part of it is registered to customer Y's vManage, and then both customers can actually control interfaces off of that router. So keep that in mind. We're not referring to data plane multi-tenancy here. I just want to call that out. This is only control plane multi-tenancy. vManage disaster recovery. This is kind of a quick one, just to highlight really quick here. Up to this point, we've supported 3-node clusters in terms of disaster recovery. If you know how the disaster recovery feature works within vManage, there's really no difference here. Right, vSmart and vBond have their own disaster recovery elements built into them just by the nature of OMP and whatnot. vManage is one of those components that never really had a disaster recovery mechanism built in, right? There's no way to, aside from a customer just replicating a database from one vManage to another, this feature allows the database to automatically be replicated and then automatically have a failover mechanism between, as you see in the picture, data center 1 and data center 2. Up to this point, we only supported 3 vManages. With 20.4, we're now also supporting 6 vManages. So if you have a customer that has a very large enterprise that has a bunch of vManages, maybe they're offloading deep packet inspection processing and things like that, flow processing or whatnot, for visibility aspects, they might have a 6-node cluster. We now support disaster recovery for that 6-node cluster. For those folks that are familiar with cloud on-ramp for co-location, and bear with me, I know this is a lot to go through. For those folks that are familiar with cloud on-ramp for co-location, there are a few new updates to be aware of here. If you're not familiar with cloud on-ramp for co-location, it kind of needs its own little session, snippet, whatever. I would encourage you to go check out some of the Cisco Live presentations I've done on cloud on-ramp for co-location, just to get an idea of what it is, what it does, how it works. The notion behind this is, for those of you that have heard of the Megaport integration that just came, or that was just announced a few weeks ago, it's the same notion, same idea, but Cisco's move with regards to SD-WAN is to move to middle mile optimization, as it's called, right? But the notion of using co-location providers as a way to optimize a lot of that east-west traffic between branches, and then optimize traffic going to the cloud, while also allowing the customer to remain cloud agnostic. See, one of the downfalls of moving forward with something like AWS Transit Gateway or Microsoft vWAN, one of the downsides to that is I'm completely in bed with Microsoft or completely in bed with AWS, right? And for some customers, that's perfectly fine. They like the features, they like the functionality, they're perfectly happy with that. Other customers don't like that. They don't like putting all their eggs in one basket. What happens if AWS or Microsoft changes some policy? They're not releasing feature updates quick enough or whatever. They change their pricing. If you are all in on that cloud provider, you are kind of stuck with it. What co-locations allow you to do is get the benefit of something like AWS Transit Gateway or vWAN or whatnot, get that optimization, get that high-speed cloud interconnect that you're looking for, while still maintaining an agnostic approach, right? Without getting in bed with one particular cloud provider. And that's Cisco's approach with this whole Megaport integration, not just being agnostic, but also automatically building the underlay between your branch locations and the cloud provider. Same concepts exist with cloud on-ramp for co-location. Cloud on-ramp for co-location is really just the DIY approach. Okay, so the Megaport integration is if I'm a customer and I want to subscribe to something, I want the same functionality, but I just want to subscribe to it. That's where the Megaport integration comes in. If I'm a customer that's a much bigger customer and I don't necessarily want to subscribe to something, I want to be able to have a little bit more flexibility than that. I want to own the equipment. I want to choose the co-location facilities that I'm going to put presence in or extend my SD-WAN fabric to, and I want to be able to do things like service chaining and put my own DNS in the transit path or my own virtual machines in the transit path of my traffic going to the cloud. That's where cloud on-ramp for co-location comes in. It's a bit more of a DIY approach, still turnkey, but DIY, right? The enhancements with 20.3, basically we're getting 9500. Again, if you want to know more about the solution, go check out that Cisco Live session. But the enhancements coming with 20.3 is we're actually getting some new hardware support for the Catalyst 9500 48Y4C. This is going to give us 100 gigabit aggregate throughput for the solution. So for those customers that need super high throughput for east-west traffic movement or traffic going into the cloud or whatnot, that Catalyst is going to provide that for us. Flexible topology, so they can cable it up however they want, and we can figure that out from vManage later. There's no more prescriptive cabling that they'll need to do. They'll be able to start, stop, reboot, and monitor virtual machines directly from vManage through this solution, and then TACAX integration has been brought in as well, since a lot of service providers will be using this to build the service off of. Last but not least, there's two more features to talk about here, but the first feature from a core update perspective is for those of you that you had customers that jumped on the bandwagon of wanting to move to ISR hardware but still run vEdge software. They might have got on the ISR 1100 bandwagon. Nothing wrong with that. They moved to ISR 1100s, and they're running the v-edge software on those 1100s. Well, now you might have some customers that are considering, now that the v-edge, c-edge parity gap has closed quite a bit, and there's quite a bit more features that you can get on ISRs that you can't get on v-edge, how can I migrate from v-edge code to c-edge code, migrate to XE SD-WAN now? With 20.4, that is now more of an automated process that's completely supported with 20.4. One little caveat to keep in mind here: they will need to upgrade to 20.4 first, obviously. So their vManage is going to have to be on 20.4, and then they'll need to upgrade the ISR 1100 to 20.4 first, and then they can make that jump to the iOS XE version 17.4. Right? So they can now start getting or gleaning benefits of iOS XE from 17.4 onward. Last thing I'm going to leave you guys with here is a FedRAMP update. So as of 20.3, and then obviously moving forward with 20.4, we are working towards our FedRAMP accreditation. I know some of you guys, this will be big for some of you guys maybe not so much. You're not even sure what I'm talking about. And if you're not sure what I'm talking about, just a quick primer. FedRAMP is the basically the federal government accreditation. Long story short, a lot of federal government agencies like the CIA, the Homeland Security, Office of Inspector General, the Post Office, all these federal agencies went to the federal government and said, hey, we want to use SD-WAN services, or we want to use cloud services like Office 365, or you name it. With all these commercial cloud services that our commercial counterparts can use, we are not able to use them though, and it makes sense from a budget perspective to be able to use those kind of services. We don't want to be able to host stuff on-prem anymore, or we don't want to have to host stuff on-prem. So even though federal agencies, they can use Cisco SD-WAN, they just have to host the controllers on-prem. Even though they can do that, they're looking for a subscription model, right? So they want to be able to host their controllers in the cloud. Now, moving forward, the federal government basically said, that's fine, we can do that. And what they did is they came up with a program called FedRAMP, the Federal Risk Authorization Management Program. And what it does is it goes through and looks at a whole bunch of cloud providers and makes sure that those cloud providers, or those things like SD-WAN controllers, right, from Cisco's perspective, or Office 365 from Microsoft perspective, they go through and they look at those services and make sure that they are secure. They're hosted on a secure platform. They're frequently audited. They have reporting that comes off on a daily basis, hourly basis. They have dedicated service support teams, all sorts of different things. There's dedicated identity management systems, all sorts of things that go into this accreditation service. So for the past several months, Cisco has been working towards our FedRAMP accreditation to allow our controllers to be hosted in the cloud and allow U.S. federal government agencies to consume those services as a service. We will be the only vendor to offer this capability. Now, from a commercial side of things, it doesn't necessarily mean anything for you folks, but it does mean that a lot of security and a lot of updates have gone into the Cisco SD-WAN solution, into the whole platform, to make it more secure and to make it more palatable for the U.S. federal government to want to utilize us in the cloud. So keep that in mind. To me, it's a selling point that we took all the extra steps necessary for the U.S. federal government to trust us, right? Now, from a controller perspective, it's the same car. It's the same engine. There's really nothing different, right? Same vSmart, same vManage, same vBond, same hardware sitting out at the branches, ISRs and whatnot. The only difference is it's hosted in AWS GovCloud, and there's a lot of other subsidiary services that have been turned on for auditing services, for identity management, for reporting. There's a dedicated TAC team, a dedicated, that's been cleared from a security clearance perspective. They can work on federal government agencies and that sort of thing. We've gone through a lot of the hoops, and there's a couple product managers that have really worked night and day to get through this auditing process, but we are almost there. We're working on spinning up our first customer right now. Once we get that first customer spun up, we can officially call ourselves FedRAMP moderate certified, and we can start taking advantage of a lot more federal customers that are interested in moving towards a subscription model. Like I said, from a controller perspective, nothing really changes other than where those controllers are hosted and a few additional services that are performing external auditing of those servers. From a hardware perspective out at the branch, again, nothing really changes, right? This is the these are the platforms that most of our federal customers already use, the ISR 1000s, 4Ks, and the ASR 1Ks, right? So nothing really changes from this perspective. The point is just to show you that a lot of features have been built in, and a lot of features that were already built in are used to feed into this accreditation that we have. So this is just kind of a summary slide for the FedRAMP stuff, I guess you could call it, that we've done, right? A lot of us already know about this 140-2 compliance. Encryption was brought in within AWS GovCloud, both at rest and in transit. We know about the in transit piece with IPsec, but the encryption at rest has been a big one. The federal government data is now encrypted within the controllers on AWS GovCloud. You know, IPsec pairwise keys. We have daily pen testing, daily auditing, and incident management that we do, real-time reporting and plan of action and monitoring that you see down there at the bottom. All sorts of stuff. The whole point of this slide is to tell you that we're doing a lot to unlock this capability. And all of this, everything that you see here, well, most everything that you see here also feeds into the commercial side as well, right? So you can talk to your customers about that. You know, there's a lot of stuff that we've done to get the U.S. federal government to trust us. So from a security perspective, it's good stuff to talk about with your customers as well on the commercial side. So with that, like I said, this presentation will be made available to you guys on Sales Connect. So you've got links to all the TDM decks that we went through here today, the 20.1, 20.3, and 20.4 TDM decks, and then a link to the latest roadmap as well. Again, before I wrap up here, there are a couple things. Again, if you're interested in that multi-cloud deep dive and you want more information on multi-cloud, AWS Transit Gateway, v-WAN, all that stuff, where are we at with that? I know that was absent from what we talked about today. It's got its own session from DT last week. Definitely be on the lookout for those links. Same thing with security. If you want more on Umbrella SIG and what we're doing there with, you know, direct peering and all that fun stuff, again, kind of deserves its own session. But it had its own session last week, so be on the lookout for those links as well. So with that, we're going to open up for some questions here, see what you guys have. I know the Q&A panel has been going kind of crazy while I've been talking here. It looks like most questions are answered, but we'll open it up for some live Q&A.
Yeah, I think before we open it up for live Q&A, I just really quickly want to call out panelists. If you could let us know if there are any unanswered questions in the written Q&A panel. We'll go ahead and answer those verbally before switching over to live Q&A.
Yeah, yes, definitely. There's one question, Aaron. This question is about V8 support for FedRAMP. If I understand correct, we are going to certify the SD-WAN code and the controllers code. But yeah, I just wanted you to clarify further.
Yeah, that's correct. Yeah, thank you. vEdge at this point is not FISMA certified as an on-prem appliance, so we're really only talking about XE devices, ISR 4K, ASR, and CSR 1KV. Or I should say ISR 1K and 4K. But yeah, that's correct, Sai.
Thanks.
Okay, any other unanswered questions? I think we might be good. I see one here. Is 8K part of FedRAMP?
Not officially certified yet, but the short answer is yes. That's the goal, is so that we can move forward with 8K. But until it's officially released, I don't have a good answer for you, other than to say yes, it will be. I just don't know when.
Okay, great. All right, let's open up for some live Q&A. If you have a question, can you please raise your hand and we will unmute you. Looks like we may have captured, oh, we got one. Let's unmute Soren.
Yep. Can you hear me all right, Stephanie?
Yep.
Yes, we can hear you.
issue. So my understanding is in the I-1100, we only support the WAN ports on the I-11. And I understand the technical details around it that McAllen chip we're using on the switch force doesn't support STT. So that's fine as such. But then I don't understand why we're claiming we can support STTs on the CSR 1000, because that would be depending on what hardware is physically in the hardware where the hypervisor is running on top. So I don't understand how we can claim STT support on the CSR 1000V.
That may be a better question for Venkat. I'm not sure how to answer that. I know from previous TrustNet days, obviously it's process software. When we claim hardware support for ISR 4K, there's a dedicated ASIC for SGT processing. But the CSR, I mean, like you said, there's a dependency on the hypervisor there, but from my understanding from the TrustSec days, and again, this is stretching back a little bit, I forget myself. A lot of that was processed in software of the CSR, but there are some nerd knobs that would need to be turned on to allow that extra header to pass through the hypervisor.
When the packet, leaves the machine, virtual machine down to the hypervisor, there should be an STT tag on that packet. When the packet leaves the hypervisor down to the physical hardware, then there needs to be an STT on the packet. When the packet leaves the hardware, the actual server that is running on, there has to be an STT tag. So you'll have to support it all that way. And that's why I don't understand how can we claim that support,
Yeah. Well, generally speaking, from a CSR perspective, it's when it's coupled with I
mean, the STT comes in under one of the service VPNs. Sure.
Yeah, I understand. Yeah. So we used to use a lot of the Nexus 1KB, and again, this is stretching back a long time for me. This is probably a better question for Venkat or if any of the other guys have a better answer for this. But was there?
It's okay.
Yeah. So let me, Soren, let's connect up with Venkat and get a better answer for that, because I don't have a good answer for it. I'm not quite sure how it. There needs to be some sort of hardware support there in order to understand that additional header within the frame.
It's good to have confirmed that you are a human and don't know everything. That's okay.
Right.
We all are human.
All right, let's last call for questions, guys. Put your hand up if you've got one. All right, I think we've got everybody. Aaron, thank you. Panelists, thank you. Great session today. We've got a lot of Q&A. Again, the recording presentation and Q&A can be found at cs.co/IBN hotline. You can also view upcoming sessions and add them to your calendar. We thank you guys for joining this week, and we hope to see you next week. Have a great day, guys. Bye-bye.